Hello everyone, welcome back to the lecture series of Basic Electrical Engineering. In this video, I am going to explain what do you mean by parallel AC circuit, how to calculate the power factor and how to compute the branch currents of parallel AC circuit. First of all, I would like to ask one question to you. What is a parallel circuit? You know, in case of parallel circuit, voltage remains same and the current through the branches are different. Two branches are said to be connected in parallel or shunt if the voltage will be same at all the branches. I mean, same voltage is applicable for branches. Suppose if there are two branches, voltage across each branches will be same. What about the current? See, current through the branches will be different. Okay, and we have to consider a simple parallel AC network which is shown in the diagram. So I am going to show you the particular diagram which is concerning for parallel AC circuit. Let's just understand the fundamentals by considering the particular diagram. As you can able to see, this is a simple parallel AC network. How many branches are there? Yes, there are two branches. This is branch 1 and this will be branch 2. What about the voltage which is applied at the particular circuit? Yeah, this is your voltage, the RMS voltage V is equal to Vm sin omega t, which is applied over there. And if I look at the branch number 1, it is basically an RL network, right? RL branch. So R and L are connected in series. So I1 is passing through R and L. If I talk about the second branch, R and C which are connected in series. How about the current? I is the total current. When you apply the voltage V, the total current is getting passed to the particular circuit. At this particular junction, current is getting divided. What are the current which are getting divided? I1 and I2 respectively. So these are the fundamentals. If I talk about the branch 1, the impedance of branch 1 is considered as Z1, where impedance of branch 2 is considered as Z2. Please recall this basic information. Now I need to write the value of Z1 and Z2 separately. How can I write? See, please consider Z1. Z1 is nothing but R plus JXL. How we can able to write? Very simple. It's a complex number, no? Z is equal to R plus JXL. So look at the diagram. This is your real part and the inductive part will be the imaginary part. Therefore, we can write Z1 is equal to R plus JXL. What is XL? XL is nothing but inductive reactance. How about the Z2? Z2 we can able to write. It's an RC network, right? Therefore, Z2 will be R minus JXC. So you know 1 by J is equal to minus J. This concept I already explained. I request everyone to watch my previous video. Then only you can understand the fundamentals. Okay. So 1 by J is equal to minus 2. Where X is known as capacitive reactance. Now tell me how to calculate the total current. So total current can be written as I is equal to I1 plus I2. Yes? Okay. Now how to calculate the impedance, effective impedance or equivalent impedance. Since it's a parallel circuit, we can able to write two manners we can write 1 by Z is equal to 1 by Z1 plus 1 by Z2. Correct? Or else we can able to write it. This is Z equivalent or Z effective. Anything is okay. Depends on how you are convenient. Therefore, Z effective value can be written as how we can write. It's of course Z1 into Z2, right? Z1 into Z2 by Z1 plus Z2. You already studied in DC circuit. There are similarity. Okay. Fine. Up to this, I think it is very clear to you. Therefore, total current will be the ratio of total voltage by the equivalent resistance or effective resistance. Now, I would like to ask one question to you. How will you calculate I1 and I2 respectively? There is a solution. You can use the current division formula. Now, please tell me how to calculate I1. So, use the current division formula. What is the total current? I is the total current. So, what is the impedance of the opposite branch? Z2. Then you can able to add the total impedance Z1 plus Z2. Likewise, I can able to calculate I2. How to calculate I2? see I2 I ought to calculate. Consider the total current I, then impedance of the opposite branch Z1 divided by total impedance Z1 plus Z2. So using the current division formula, I can easily compute I1 and I2 respectively. Based on this particular concept, you may get numerical example that I am going to solve in the coming session. Now I am going to ask how to calculate the power factor. So power factor is the ratio of R by Z in case of AC network. Here R means R effective and Z effective means the total impedance, or you can write R equivalent to the Z equivalent. This will be the value of power factor for this particular circuit. Okay. Now let me ask one question: how will you calculate the power? How to calculate the power? So what is the formula to compute the power? Consider the first branch, it's an RL branch. P1 is equal to VI1 cos phi 1. Why do you write V? Because it's a parallel circuit, same voltage is applicable for branch 1 and branch 2 respectively. So if I talk about the branch 2, P2 is equal to VI2 cos phi. Here also voltage remains same, that's why I have written as V. Therefore, if you want to compute the total power consumed in the particular network, that is given by P1 plus P2. It is nothing but VI cos phi. So tell me what is the value of power consumed in this particular circuit, parallel circuit, VI cos phi. Hope you understood the concept. Now tell me how to draw the phasor diagram. Very simple. I can help you how to draw the phasor diagram in a simple manner. What you are supposed to do is, now identify the common quantity, the quantity which is common. See, the voltage remains same, no? So please write it as voltage V. Yes. Now let us consider the branch number 1. See, it's an RL network, no? What about the position of I1, current through RL network? It is lagging, right? So compared to the voltage, I1 is lagging. So I would like to write it as I1. It is lagging at a certain angle. Let me call it as phi 1. Correct? I'll be writing phi 1. When it comes to the branch number 2, what about I2? Look at I2. How about the behavior of I2? Since it is a capacitive circuit, current leads by the voltage at an angle of phi, right? So I would like to mark, this is your, obviously this is your I2, correct? I2 leads the voltage at an angle of phi 2, correct? Yeah, please note down accordingly. Now there will be a resultant current. I is the resultant current. Probably you can draw the resultant current in this fashion. Correct? Now you can able to complete the parallelogram. So please to complete the parallelogram. Like that you can draw. If you draw in a scale, you will be getting the proper systematic diagram. Time being, it's okay. Understanding is important. So this is actually the phasor diagram look like. For your convenience, I have drawn the phasor diagram at bottom. So this is the way how to draw the phasor diagram. Hope you understood the concept. And also one more thing, the total current leads or lags the applied voltage depends on the circuit, whether it is inductive or capacitive in nature. So I have explained in detail about inductive circuit, capacitive circuit, and the different analysis I made out. So I request everyone to go through it so that you will understand the concept very easily. By the way, let's conclude the session. So in this session, we have discussed what is a parallel circuit. Later, we directly explain the calculation of I1, I2 and the total current I with the help of a simple AC parallel circuit. And also we computed the power factor, right? Then we computed the total power consumed. Ultimately, we have drawn the phasor diagram. I have explained the step-by-step procedure of drawing the phasor diagram. If you have any questions, please put up in the comment box. I am very happy to reply. And also kindly go through the previous video to understand the concept very clearly. Let me conclude the session. In the next session, I am going to discuss about the problems related to parallel AC circuit. Thank you very much for watching this video.